Good morning or afternoon, class. Here is your warm-up for today. I'd like for you to go ahead and pause the video and take about 5 minutes to do these 5 questions involving polar coordinates, parametric equations, as well as vectors, and just a little bit of everything. All right, so I'm going to list out the answers for this. For A, there are 4 that I have here, or 3 others that I have here. That's -2. Oh, it's really thick. 45 degrees, and then 135 degrees, and then -225 degrees. Let's do the rest in purple. That would be 6, -4 pi over 3, -6, -pi over 3, and -6, 5 pi over 3. Remember, what we're doing is taking the original, adding 2 pi or subtracting 2 pi, and then from the original, flipping the signs and making them the opposite, and then adding and subtracting pi. All right, let's move to number 2. So it's given this parametric equation. We are going to give the parametric equation given this. Well, this is an ellipse, and as we discussed in class, you're going to write this as x equal, I need to switch this size. This is kind of ridiculous. Maybe there. Let's try this. X equals 3 cosine theta plus 2, and y equals 2 sine theta minus 5. So as we talked about, the center is 2, -5. So that's where this 2 came from. That's where this -5 came from. And then we have 3 for the horizontal radius and 2 for the vertical radius. Number 3, answer is -8 root 13 over 13 and 12 root 13 over 13. Number 4, you're asked to find the bearing. So that would be 7 cosine of 120 and 7 sine of 120. So we could write that as, yes. So we're going to write it as -7 halves and 7 root 3 over 2. Convert the coordinate. We talked about this last time. So this would be root 34. And then using your calculator, that's pretty good. A lot of different things for this warm-up. Check it out, and let's move along. All right, for today, we are going to convert between polar and rectangular equations. Before we were doing polar to rectangular points and back and forth. Now we're going the other way with an actual equation. So let's take a look at some basic equations, see if we can put together what we know about these. So this breaks down the idea that a polar graph is a set of all points with the coordinate of r theta that satisfies a given equation. For instance, r equals 2. Well, that means no matter what the theta is, so theta is 0, r equals 2. Theta is pi over 4, r equals 2. Theta is pi over 2, r is 2 still, r is 2, r is 2, r is 2. So what we're actually building is our circle that we already know, okay? So we want to be able to, we just graphed the coordinate to theta, no matter what it was. Now, the tricky part for theta equals pi over 6 is that that means that the theta is constant. So if we're going to write all points, but our radius changes, so pi over 6, remember, is right here. So if we're at 2 pi over 6, or sorry, pi over 6, yeah, I guess 2 pi over 6, 1 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. Now if we go in the negative direction and we go -1 pi over 6, we're here. Because remember, positive is this way. So this would be -2 pi over 6, and then we go all the way down So the big difference between these two is that r equals 2 is a circle and theta equals pi over 6, we have an ordered pair. Now, let's go ahead and graph each of these and label them. So we have r equals 1. That is going to be which one, a line or a circle? Should be a line. R equals 1. It's not the best, but that's what we got. Theta equals 5 pi over 6. So theta equals 5 pi over 6. We go, that means 5 pi over 6 is over here. So we can go ahead and put a few dots this way and then some dots this way. And we have a line. Boom. 5 pi over 6. For the next one, let's do, I guess in green as well, r equals 5. That would be the circle. 1, 2, 3, 4, 5. And then for 225, where is 225? It is down here. So we're going to be able to draw this line all the way through. Remember, the other side of the pole is used for the negatives. Negative radii. Okay. So now we're talking about converting equations. That was just a quick little reference to when you have an r equals a value and the theta equals a value. But now we have conversions. That is our goal today. And this is what I call our toolbox. X equals r cosine theta and y equals r sine theta. And then we also know that r squared equals x squared plus y squared, which I guess you can write as r equals square root of x squared plus y squared. And then theta equals tan inverse of y over x, and theta equals tan inverse of y over x, and then tan theta equals y over x. Those we will use to help us convert. Let's try it out. So we have all the information at the top, and say we're given some random equation that says r equals 4 cosine theta, and it doesn't say to graph it, it just says to put it in rectangular form. Well, if you're looking good at this, you're remembering a little bit from when we graphed to know that this is a circle. It's got a radius of, it's got a diameter of 4, and it's hugging the x-axis because it uses cosine. Let's see what would happen if we follow the rules. Well, r equals 4 cosine theta. I'm going to give you about a minute. I want you to pause the video now and then see if you can figure out what to do using all these little pieces, these tools in your toolbox. All right, well, let's go ahead and start it out. The first thing you need to recognize is that r equals the square root mess, and that's not here. And then we do have a cosine, which is not what I see up there as an r cosine. So if we multiply both sides by r and put it in a very strategic place, you end up with r squared equals 4 r cosine theta. Now we can change things a little bit. We were told that r squared equals x squared plus y squared. And then we also know that r cosine theta is x. So now we're going to have to move everything onto the same side. And then we have to half and square. So half of negative 4 is negative 2 squared is 2. Is 4. And then we add it to the other side. And we end up with y minus 2 quantities. That's not a y. Pardon me, everyone. X minus 2 quantity squared plus y squared is equal to 4. So that means we have a radius of 2, and we're centered at 2, 0. Now, if you went and graphed this off to the side, remembering what you know about the fact that I said earlier, 1, 2, 3, 4, and it's this type of circle, well, yeah, duh, the center is 2, 0, and the radius is 2. So if you make that connection, amazing. That makes your life that much easier when we're transferring our coordinates from polar to rectangular. Let's try another one. R equals 5 cosine theta. Well, pause the video and try this out for yourself. Okay, so if we have r equals 5 cosine theta, I know that cosine is the same as 1 over sine. And then if you multiply the sine over, you get r sine theta equals 5. And that's y equals 5. So that is the line y equals 5.